Well, good morning, everybody, and welcome to the latest in our Aqua Agenda series. Today, the topic is technology, remote monitoring, and artificial intelligence. And I'm delighted to say our co-hosts for this session are communications tech business Krucial. On our panel today, we have Kevin Quillien, CTO and co-founder of Krucial, Professor Keith Davidson of the Scottish Association for Marine Science, SAMS, Kristian Blom, CEO of AquaCloud in Norway, and joining us from Tasmania, Tim Shepherd, who is Senior Manager, Smart Farming and Feed with aquaculture business Tassal. We'll start with an introduction to our panel members and then move on to a wider discussion. On your screens, you'll see a dialogue box through which you can put any questions you may have for us. Kevin, if we can start with you, what is the problem that Krucial set out to solve, and how have you tackled it?
Thanks, Robert. Hi, everyone. So fish farms, especially offshore ones, can be sort of seen like small factories. Typically a factory will be built where, is most convenient, where all the resources are available, everything it needs is available. But the offshore ones are typically located not where they prefer to be, but where the sort of concession, a license allows them to be. And so offshore factories can be located really, really far from everything. These are complex systems. They can be really challenging to operate, very expensive when things go wrong. And so, yeah, digital and digital transformation, digital twinning can really help offshore farms. It can provide operators with critical information 24/7, allow operations of issues, allow remote or even partial autonomous operations, maximizing site productivity. So there's a real need for digital across the whole, aquaculture industry, across entire organizations, even reaching to the most remote offshore farms. There are lots of challenges to digitalization, companies tying themselves into vendor-locked systems, limiting value that these can bring, an increased reliance on digital once it's implemented. Once you start to use digital tools in your day-to-day operations, it's really difficult to stop. So these digital technologies need to be resilient and dependable. AI, which we'll talk about a little bit further in this webinar, can be a bit of a trope at the moment, but it's got real potential in the industry, and AI needs dependable digital on which to operate, and then of course adapted to the conditions offshore. We saw Storm Eowyn. It took parts of my roof off here in Glasgow, which has been fun over the last couple of weeks, along with the local Lidl. But our kit off the west coast of Ireland, which probably saw the worst of the storm, brushed it off and kept on working. So really what we want to do at Krucial is we want to make digital accessible to the whole global aquaculture industry. We want to help digitally twin global aquaculture. Very small task. And we're doing so by tackling all these barriers that I've just mentioned, the industry pain points. We're providing the sector with digital solutions that are tailored to its needs, underpinned by a technology that thrives in the most demanding conditions and really offers the scalability, the dependability, the adaptability that the sector expects, or at least should expect from digital solutions. That's us at Krucial. Thank you.
Great, thanks, Kevin. Professor Davidson, what is the role of SAMS, and how does it relate to the commercial business of fish farming?
Okay, thanks, Robert. Well, for those who don't know, SAMS, we're a sort of independent marine research organisation based on the west coast of Scotland that we also deliver teaching via UHI and, to balance the book, some commercial activity. And we do quite a lot of work related to aquaculture and fish farming. Examples are a model called New Depomod that a lot of organizations use to look at the benthic footprint of fish farms, and quite a lot of work on sea lice modeling. My particular interest is related to phytoplankton, and so for aquaculture, that's primarily harmful algal blooms that can cause health issues and potentially mortality of fish. And we're beginning also to study the role of micro jellyfish that's operate, I guess, in a similar fashion in terms of impacting gill health and things like that. So we've worked in a variety of ways. Traditionally, we simply used microscopy, using a lot of staff time, a lot of people sitting looking down microscopes, and it probably remains the gold standard, but it's time consuming, it's quite difficult, and so yeah, we're looking for technology that can do things at least as well, and certainly faster. So we've had quite a few projects over recent years to try and develop these new technological approaches, and also not to discard the microscopy data, but perhaps to use it better. So first thing was a SAKE-funded project that was basically identified the issue that, fish farming companies, a lot of people do phytoplankton counts maybe on a daily basis, but the companies don't necessarily use the same methodology, they don't necessarily use the same taxonomy, and they don't share the data, or they didn't share the data. So we've been trying to look at ways of standardizing those approaches to make sure everyone samples in the same way, counts in the same way, and then can upload data on some platforms that we've developed that allow that data to be shared by the participating companies, and also to initiate some mathematical models that we have that allow us then to give a forward-looking risk assessment of whether where blooms might begin to proliferate. The other thing that we're looking at is basically, I guess, optical technology, particularly a thing called an imaging flow cytobot, which is basically an in situ phytoplankton counter. It will take a picture of every single particle, and we tend to trigger it on chlorophyll, so we get every single phytoplankton cell in a water sample. And it'll do this very, very quickly. It can do a sample every 20 minutes, as opposed to cell counts that are probably done at best once a day. And it can generate huge amounts of data. We've been trialing this for about the last 18 months at a Scottish Seafarm site in the Shetland Islands, and in the process of generated something like 57 million images of phytoplankton. So it's almost too much data to deal with. So what we need is ways of processing that, and so we currently have some projects looking at development of basically neural networks to take that data in, to assign it to the appropriate phytoplankton genus or species if we can, and to report that in real time. And we're finding that operating really quite nicely. We've got relatively little downtime, and been able to operate basically this monitoring and early warning system for, as I say, for about 18 months. And in parallel, we're trying to make some environmental measurements as well to help us better understand what's causing the blooms and hence improve our predictions. Okay, I'll pause there.
Thanks very much, Keith. Kristian Blom, you're CEO of AquaCloud, which was set up by the Norwegian fish farmers to help share and aggregate the data that they collect. Can you tell us some more about AquaCloud's mission?
Yeah, sure. Yeah, as you said, AquaCloud is an industry initiative started to see if fish farmers can solve some of our challenges or understand more about our challenges that we share by using data. So we've set up a data sharing platform, and currently we have 32 fish farmers joining us, and that's farmers that have one site and farmers that have 100 sites. So it's the whole spectrum of Norwegian fish farming. And we're still onboarding and recruiting new farmers. And the mission for us is to enable the farmers themselves, researchers, suppliers, to get access to data sets that they can use to improve and help understand more about what's going on in our production. I guess I would say that we strongly believe that data and digitalization is going to be crucial to solve some of the issues we're seeing, and us being an actor that can facilitate big data access to be able to understand across farmers and sites and regions in Norway. Of course, this is transferable to other regions as well, but currently we're only working in Norway. It's not a secret that it's pretty challenging to get a company like this to set up. You have to have companies voluntarily join and share data. So it's a pretty strong data governance framework and legal framework that we have to set up and kind of run the whole business inside. But yeah, I think what we're seeing now is like a growing understanding of the importance of transparency through data, and we're seeing an increase in new digital solutions and an increase in data being collected. So there's hope that we through AquaCloud can do some good for the entire industry, but also for the single farmer as well. So yeah.
Thanks, Kristian. And finally, Tim Shepherd, you have a role in Tasmania, but also across the worldwide organization of Tassal's parent company, Cook. Can you tell us something about that and about how technology is changing the way Tassal and Cook operate?
Yeah, sure. So part of my role is overseeing our remote operations centre, which is in Hobart in Tasmania. And we established that centre back in 2018. And currently we remotely feed and monitor the equipment and stock on our salmon farms in Tasmania and our Barramundi farm in far Western Australia, which is 4,000 kilometres away from the remote operations centre. And it's my role sort of evolved into a bit more of a global focus since we became part of the Cook Group. And we've had a lot of collaboration on remote operations and fish performance and important technology with the regions such as Canada, the Mediterranean, Scotland and Chile. So it's been a really good opportunity to learn from each other. And if I think really high level about technology and what it has enabled for us in fish farming, is it allows us to make data-based decisions every day to achieve the best commercial outcomes. And it's allowed us to move away from the historic qualitative or gut feel based decision making that a lot of farmers used to make. So yeah, technology has been really powerful for us.
Great. Thanks very much, Tim. So if I can throw open the discussion with some questions for the panel as a whole. I think, Kevin, you touched on some of the challenges for fish farm sites and solutions. What is it about fish farming that makes it particularly challenging? And I'll go right to the other panelists for this question as well. But to begin with you, what is it about fish farming that makes it particularly difficult in terms of communications and transferring data?
Yeah, communications and connectivity, I guess, are is one of the important attributes for digital solutions. It's very important, but it also can't really be tackled in isolation. And I think digital needs a lot of things working together in order to and working in concert to add maximum value. And I think aquaculture is challenging for communication, connectivity, and a lot of the other attributes as well. So it is a difficult industry to digitize for many reasons. And in terms of some of the solutions we see available today, there's a few SCADA-based sort of systems that are inherited maybe from RAS and sort of onshore operations, but a lot of these might not be well adapted to offshore for many reasons, connectivity being one of the challenges. They can be very expensive, especially up front. And yeah, need a lot of supporting infrastructure, which may or may not be available, or might be available on some sites, not available on other sites. Whilst, for us, a comprehensive digital twinning of a sector means, having a consistent digital infrastructure across, an entire operation, and not sort of picking and choosing different capabilities depending on the site. The best value is when there's a nice consistent digital twin across an organization. We've seen some other solutions as well on various customer sites. We've seen sort of consumer grade hardware and solutions, Wi-Fi, 4G, with some very questionable reliability and consistency in the data and their performance, which can be a real challenge when you're trying to get a lot of value from the data. You can't have huge blind spots and gaps in your data, or inconsistent ways of collecting and measuring data across sites, because how do you then compare and figure out if something is actually wrong? We've seen a lot of DIY systems that can be a real cybersecurity nightmare. I mean, Kristian touched on the data governance and the importance of everything being secure, and that can be really challenging when things are sort of stitched together. There's other sort of specific solutions like point-to-point microwaves, which works very well when it works, but can be really challenging and costly to implement up front. And as we've seen here in Scotland, bouncing signals above multiple islands can there's maybe a bit of a tricky way to run your operations. And then I think a large part of the industry, maybe not so much salmon in Scotland and Northern Europe, but aquaculture generally, a lot of manual data points, a single sample collected at 8 a.m. Every day, but fundamentally no idea of what happens at night, what happens across an entire site, pen by pen, beyond the site, upstream maybe. If you can't travel to site because there's a big storm, then that's no data points at all. And then, when it's collected, where does that data go? Is it made accessible to the people that need it? So yeah, lots of challenges, I think, today with getting better data. Connectivity and transferring that data is definitely one of the important ones. And, we feel that the industry needs dependable digital monitoring and control, a capability that works where the farms are, all of the farms. It has to be resilient to the conditions on farms. It has to adapt to the differences in farms. You see all sorts of different kinds of farms, especially when you go multi-species. We've deployed on wooden farms with close to 100 pens. We've deployed on shellfish farms as well, where there's no infrastructure, everything's underwater. So yeah, but the global aquaculture, really needs digital that can adapt to the different conditions on site. And then, of course, it needs to solve the problems that the industry faces. Sometimes you get a lot of digital solutions that are inherited from other industries that are simply not adapted, and dashboards that don't work the way the farmers think and things like that. So, and then just to sort of promote ourselves a little bit, we have designed the connected Seafarm, the Krucial flagship product, to solve these problems and do precisely that, solving the challenge of connectivity, a lot of, as well as the other barriers that are in the way of dependable digital solutions and digital twinning, and one that can be rolled out, across whole organizations across the world.
Thanks, Kevin. Tim, does that picture sound familiar to you? What sort of challenges are there in terms of the farms that you're managing remotely at Tassal?
Yeah, absolutely, Robert. So one of the biggest challenges for us is that some of our growing areas are in quite remote locations and are often exposed to big waves and strong winds and things like that. So that's definitely a challenge when setting up an appropriate network to maintain connectivity back to an operations centre, as Kevin touched on. But the fact that our network connectivity between the farm and the ops centre is rock solid, to be honest, has enabled us to take advantage of certain things. So a really basic example is historically we used to have operators go out to a feed barge every day to feed, and they'd travel by boat. And if the conditions were too rough, you simply couldn't get people to site safely. Whereas now the fact that we feed from the capital of Hobart from a land-based building means that when conditions allow with that network, we can feed with confidence. So it's actually allowed us to get around an obstacle that we had historically with a reliable network, for sure.
Kristian, does that also sum up the kind of challenges that farmers are facing in Norway? I mean, obviously you're dealing with the data coming in, but that data has to be transferred and it has to be kind of reliably collected.
Yeah, I think what we're seeing as we're also doing initiatives within data quality and standards, and like Kevin touched on, like there are data being collected like manually, and some data has to be collected manually. And what we're seeing is even within companies, there are different standards on how you do this, right, and how you register data. Like what I think we're seeing in the industry in Norway, at least, is a growing understanding of the importance of a digital strategy, at least in some of the companies, and especially, of course, the larger companies with more resources. But I think a lot of the challenges we're seeing is the kind of the lack of the digital competence and the understanding of the importance, and also the willingness to invest in the necessary resources to do this in a good way. But then again, it goes back to the suppliers. What value are we creating from the digital tools that we're giving that can actually make a difference? Because I think we also have to remember that there's been a lot of good business done on on the existing infrastructure, even if it's limited. So I think we have to have a focus as suppliers and people working in the industry to have the kind of what's the value proposal and what's the return on investment of the systems that we provide for the industry. So.
Thanks, Kristian. Keith, west coast of Scotland and the Northern Isles, where the main part of aquaculture is carried out, those can be pretty challenging environments as well, can't they? Does that I mean, for example, you've got your Cytobot out there in Shetland, in all weathers. What kind of challenges are you facing in terms of getting the data that you're analyzing?
Yeah, I mean, they certainly, they can be challenging environments. And to be honest, we've been pleasantly surprised by our ability to get data. We're simply transferring it over the 4G network, and there has been occasional dropouts, but that has worked. But that's, as clearly the coverage isn't universal in the whole of the west of Scotland. So that you could certainly have problems, and we do need better means of connectivity. I found that we've had to purchase pretty high grade and expensive equipment. The Flow Cytobot is far from cheap. It's well over £100,000. And we've got some parallel environmental monitors like a CTD, which is a UV system on it to prevent biofouling. So the minute you put something in the water, it's going to foul, it's going to have issues. And I think at individual sites, we're getting the technology is sort of getting good enough to work, but it's still requiring a fair bit of investment and time, and a lot of money. So I think that there's a real need to probably understand the oceanography, understand the ecology, that we can better site these expensive instruments in sentinel sites, that they aren't just protecting one farm, but they're protecting a group of farms. And hopefully being able to spread the cost of this technology. And technology tends to become cheaper over time. But at the moment, it's the state of the art is costing a lot, and I could see how there's maybe concern about investing a lot in quite new technology. And so if there's a way of spreading that between companies until it becomes perhaps somewhat more routine and more affordable on a per farm basis, it would be a good way forward.
Thanks. Now we've got a couple of specific questions from our online audience. One is actually for you, Keith, about SAMS. Who is funding the work that SAMS is doing, particularly with regard to phytoplankton and this kind of alert for harmful algal blooms?
Oh, sure. Well, quite a variety of people. I mean, the work initially came out of work that we did with the shellfish industry and still do. We monitor for the Food Standards Agency. We do phytoplankton monitoring, and that commercially, and that led to us beginning to build the system. The specific finfish work we've had a series of projects funded by SAIC, Sustainable Aquaculture Innovation Centre, and we also get funding. We have a current grant from BBSRC, so effectively UK government research funding, that's working on the phytoplankton and developing this micro jellyfish system that we're working with University of Aberdeen, who have a holographic camera. But very similar problems that we need to develop an AI system to process these images. And over the years, we've had funding from the EU as well. So basically, yeah, a spread of both research and commercial funding.
Thanks. And Kristian, I've got a question particularly for yourself as well. Do companies get compensation in return for sharing their data with you? And is that data publicly available? And do you charge for receiving the aggregated data that you collect?
We don't pay farmers to share data to us, but we do give them some data back. Like, if you understand, like it's so I guess that's kind of the payment there. Of course, we do have some data that's public, but it's also limited in part of our because of our data governance and the fact that we have to approve recipients and like everything being in accordance to the governance that's set up. And yes, it is a commercial model connected to this, and that's our way of making money, I guess. So I think we have to say that data has value, but it's pretty hard to set a value on it. But one of the things that we've seen, imagine like from our part having about 30 companies sharing data with us. We know that for many research projects, there's a lot of resources being used by collecting similar data, building data platforms, and doing all this work themselves, which is actually very costly, but sometimes forgotten when you do these projects. So I think everybody, like from our perspective, for us to be able to do this, yes, there is a commercial part of things. So that being said, we do have some open data and, like, for instance, some environmental data and stuff like that. Yeah.
Okay, thanks. There's also a question drawing parallels with another branch of agriculture, food production, the poultry sector, which has made significant advances in using imaging technology as a tool for monitoring behaviour, so for subsequent analysis by AI. Does the panel see evidence of this approach being successfully deployed in aquaculture? Tim, have you guys been looking at analysing fish behaviour? I guess what you're seeing fish doing is going to tell you a lot about their welfare, about how they're interacting with their environment.
Yeah, absolutely. So each of our salmon pens have a winch camera or dynamic camera installed, which allows vertical and horizontal movement throughout the water. And we've used AI software for monitoring feeding and response to feeding as well. So that's to make sure that you're hitting true satiation, maximum growth each day with the lowest possible feed conversion rate. And there's also development going on relating to the health and welfare of the stock as well. So looking at things such as swim speed, fish behaviour during certain environmental conditions, and that information, if developed effectively, could be quite powerful in, ensuring optimal conditions and husbandry for your stock.
Kevin, any thoughts on that? Is it an interesting avenue to look at examining the fish behavior and kind of finding ways to analyze that?
Absolutely. I think fish behavior is definitely one of the most promising applications for AI in aquaculture. I think, AI is suffering a little bit from being in the news all the time at the moment. And it's turning into a bit of this magic wand that you can shake at any problem and it'll solve everything and anything. But as far as we're concerned, AI for the foreseeable, at least, is very much going to be a tool, and it needs to be applied to a specific problem or set of problems to be useful. And definitely, I think AI in aquaculture at the moment, the big value will come for doing things that humans simply cannot do well. And one of them was mentioned earlier, digesting huge amount of images. For example, Professor Davidson's 15 million algae images. No human could possibly do that. But another one is, of course, staring at dozens or hundreds of camera feeds day in, day out, and inferring from that, fish behavior, and therefore, being able to adapt feeding and extract loads of other information. So yeah, fish behavior is absolutely something that AI can be applied to, and we've got a project at the moment that is initially focusing on optimizing feeding being the most costly operation throughout a fish growing life cycle. Any optimization here is can have immediate impact on stock performance and the bottom line of a site and a company. So but looking at the fish behavior, and what we're wanting to do is add all the environmental data to that. So we're working with a partner on developing some early models there as well, and looking at the camera feeds, looking at the data feeds, looking at all the available relevant information, and seeing if we can really get a complete picture of the fish behavior and make better decisions when it comes to feeding. And then, of course, there's all the other things that you can then derive from fish behavior, the things that you can't stick a sensor in and understand, things like the stress of the fish and being able to determine whether or not you want to carry out a handling operation or whether it's too risky. There's a lot that can be derived from all of this. And, at the moment, it's quite a tedious job. A lot of people are having to sit and stare at camera feeds, a lot of camera feeds a lot of the time. So we see AI as being able to hopefully help those members of the aquaculture industry and have maybe a less arduous job and do it better, more effectively, and not have to sit on site, for example.
Thanks, Kevin. Any other thoughts on that one? Behavior monitoring.
Yeah, I think we're seeing this a lot now. I actually worked for one of these companies for a few years that does computer vision, and seeing how it has evolved over the last years now in the industry been very interesting. Going from like a very promising, not sure if it's worth it, to now kind of seeing results and decisions being made. Very interesting. And as Kevin mentioned, feeding is also something I think a lot of farmers strongly believe can really help the industry because it's kind of taking away the human assessment that can vary a lot between each person. So I think it's a very exciting technology that we're seeing being evolved.
And I've got a general question for the panel as well. Are there other marine sectors which are using data from remote sites and digital twinning? And how does aquaculture compare? And can aquaculture learn from what is happening? I'm thinking particularly the energy sector and renewable energy sector, I guess, is one that comes to mind. You've got sites out there that will not necessarily have eyes on them and in some challenging locations, but I guess you want to know what the stresses on your wind turbine are and things like that. Is that something that the aquaculture sector is looking at?
I'll jump in with maybe a little cheeky answers. I mean, of course, yeah, the energy industry, particularly oil and gas, has been digitizing since there's been digital. We've got a lot of offshore production facilities, also factories on the water. But obviously, the main difference is that the depth of the pockets and therefore the scope of the solutions that can be brought in, which a lot of times is significant. Number of zeros at the end of the leading digit. So there is a lot, but whereas the oil and gas industry can afford to build very advanced bespoke solutions to each and every one of their problems and have huge teams of engineers and within the organizations that can go and do all of this work, the aquaculture industry doesn't have that luxury. So what we need to do is democratize a lot of that capability and make it more affordable, make it more accessible, and adapt it, of course, to the specific use cases and needs of the industry. So no direct, we'll just take this from oil and gas and stick it on a fish farm. But we're trying to build as many of these bridges as we can at Krucial.
Okay, we also have a question about data and transparency, and this kind of enters the difficult area, which I think Kristian had already touched on, which is how much data can you actually put out there? The question was, fish farming is under a lot of pressure from the anti-farming lobbies. Could making more data publicly available by showing that fish are healthy and behaving normally help improve the industry image? In other words, if you could log on and say, hey, look at those fish from insert name of fish farming company here. Yes, if you're looking to find unhealthy fish and you keep visiting sites, you're going to find some unhealthy fish. But the vast majority of those fish are actually swimming around, looking in the peak of health. Is that the kind of thing that would help, or is that the kind of thing that would be rather worrying for the farmers? Maybe perhaps unfairly, I'll go to you first, Tim. You've got your farms. I know that Tasmania, just as in Scotland, there are people who are not fans of the industry. Would making more information available help, or would that be problematic?
I think it can help. One key observation since we started our remote operations centre is we have a lot of visitors. Visitors come through, and some are supportive of the industry, some are not. And I think a key observation is they're quite surprised at how advanced the technology is that is being applied in the aquaculture industry compared to other industries, and the amount of care and effort that goes into looking after the stock and making sure that they're healthy, happy fish. So I think it can be worthwhile, definitely increasing that exposure.
Keith, do you think more information out there, maybe even the ability to see fish swimming around, is that something that might get more of the public on side?
I think you'll get a range of views from the public, probably, but I think transparency is probably usually better. If you hide things, people perhaps think you're hiding more than you are. So I certainly think, certainly in terms of data being out there, I think that. Oh, oops, my lights have just gone off. that allows people to do analysis that will perhaps be beneficial for the industry, and maybe in ways that we don't quite understand, that there may be tangential spin-offs. People do analysis, say, well, this this is useful stuff. If you put data out there, I think there'll always be some people will see a negative from it, but I would think the majority of people might benefit from that. We certainly, the phytoplankton data that we moving to the shellfish sector is all publicly available, and that could be perceived as a negative. Oh, there's toxic shellfish in such and such a site in such and such an area. We don't really see that. We don't see. I'm not getting many emails saying, well, the shellfish industry should be shut down because there's this potential human health implications at certain times. So I think probably on balance for the fish farming industry, more information out there would be better.
Thanks. Any other thoughts on that one? Transparency, or any downside to that?
I think what I'm hearing is, yes, we're positive to share, but there's also always context, and sometimes context is not apparent, like it's not obvious from data. So I think there's something about like seeing the full picture here that scares some people, because data can also be used against you, also unfairly. So I think there is a case to go an extra round and think about this. Yeah.
Okay. And Kevin?
Yeah, I think I totally agree with Kristian. I think, maybe this is a little bit philosophical, but we saw with the internet, connecting everyone and providing all the information at everyone's fingertips, and yet we're heading into an era of unprecedented misinformation. So, I think it's how the transparency is done. I think Tim's, talking of real engagement, having people see it for themselves, I think is a fantastic way to have transparency, and is a really good way of showing people that the industry. But dumping a whole lot of data out there, I think is probably the wrong way, because there are a lot of people who don't want the best for the industry, and like Kristian said, can pull data out of context and make it say whatever they want to say. And so, yeah, it's a double-edged sword. Transparency, I think, is better if it's done right, but can also damage if it's done wrong. So I think that's probably, I'd assume that's where a lot of the reluctance is when it comes to sharing of data, is not necessarily just wanting it all out there for anyone to misinterpret it there.
We've got a question which is directed to Kristian, although it may be something other people would like to jump in on as well. Data only has value if it gets processed and analyzed, and farmers need insights from that data. Now, the questioner has said the most important is to handle the data in accordance to data management plans. Is that a phrase that people are familiar with? I must admit, I'm not really myself. So does culture around data need to change? I suppose particularly if we're dealing with farmers, if we're working with farmers who are used to a sort of traditional way of doing things, do you need to kind of change the culture of the way the farming business operates for them to get the most out of the data that they're getting?
Yeah, I think you're right. There is a cultural thing, but there's also like the complexity of farming is high here. You have the technical aspects, but you also have the biological aspects, and you have all the infrastructure surrounding this. So making data-driven decisions is not always something that's easy to do. So building a culture is something that's going to take a lot of time, a lot of effort. So you need people inside your organization that has that mindset, definitely. And I think, as I said, we're seeing more and more of that, and especially the younger generation that we're seeing coming now, being used to to like even from their studies, handling a lot more data and like coming out there having skills to handle data actually, which is very interesting, and it's going to be something that I think will make this go a lot faster in the years to come, because there's a lot more skills on data handling now in the younger generation. Yeah.
Any other thoughts on culture and data at the human end of things? I mean, sorry, Kevin, you were going to say something.
Yeah, no, I think it was just to agree with Kristian. You know, I guess you could call this some sort of data literacy. You know, we've had in the past IT literacy, where the training members of organizations to use computers and the sort of hardware, digital elements. But now it's a step beyond almost. Is the data literacy, having a fundamental understanding of what data can do, but also the limitations, because data can be used wrong, and so having that spread through an organization, you almost get a free upskilling, and your whole organization can then start to use data better and understand the value of data, and will invest in it and the tools and all of that. So yeah, absolutely.
Tim, you're dealing with colleagues from locations around the world. Are you finding other different approaches in different fish farming regions of the world to data, or is it really a matter of the fish are the same, the technology is the same?
I think if you look at different species, they may have slightly different biological characteristics, but ultimately there are a lot of theories and principles when farming any species that you can apply. One thing I did notice in that question was insights and using the data to get an insight, so to make powerful decisions. And I think, as an example, in our operations centre, we collect 2 to 3 million data points per day. So that's a lot of data. And I think a lot of fish farms are similar in that they collect a lot of data, but it's what you actually do with that data to allow you to make powerful decisions or get insights. So I think that's really important. And it was touched on earlier in the webinar around high quality data, or good data hygiene. I think that's really important. So one thing I have noticed in different regions, some people are very reliant on that one sample. I think Kevin mentioned it, that's collected at 8 o'clock every morning, whereas other regions will put more focus on continuous or real-time data. And I think having real-time data of powerful parameters that has a high level of hygiene allows you to make really powerful decisions with it. So that's something that I have seen that can vary from region to region, and it's about applying the learnings from one region to all regions to bring everybody up collectively to the same level and utilising data in the same way.
We've got a few questions coming in, which are really on the theme of disease. Obviously this can be a massive problem for fish farmers if you've got a bacterial or viral disease affecting the fish. Any thoughts on how this kind of remote monitoring, and particularly in conjunction with AI, can help to identify and ring alarm bells when it comes to disease, and if so, how do they do that? And who wants to step on that first? Kristian, were you going to say something? Go.
Yeah, I can start. Since I've also worked with this, but what I've been working with before and what we see growing now is welfare monitoring. Where I guess is kind of the term that's used a lot, but basically using cameras to observe, for instance, wounds, which is a big problem in the industry. We can see deformities on the fish. We can see different traits of the fish that kind of needs us to at least know about it, but also sometimes take action. And we're getting reports that people are using these cameras to make decisions that save them a lot of money. Yeah, I think it definitely has a place, and we've just seen it, like the beginning of it.
We've also got a question about environmental DNA sampling. Now, I know a lot is happening on this on the scientific front. Keith, I know some of your colleagues and SAMS are quite interested in eDNA. Do you think this could be a technology of the future that could be used on a more commercial basis rather than just for academic studies?
Yeah, absolutely. I mean, I think it can work in a number of ways. On the phytoplankton side, it's a technique that can and is used. It's probably less quantitative at the moment than microscopy or the optical approaches, and clearly you have to go out and take a sample and then process it. Whereas the optical approaches, like I was talking about earlier, can do it routinely or not remotely at the moment. But there's other approaches. A colleague here at SAMS, Tom Wilding, is developing eDNA approaches for benthic sampling. So instead of having to collect samples to look at the benthic impact on the marine fauna, that can be done via potentially a lot quicker via eDNA approaches. So yeah, I mean, certainly I think molecular technologies are great advances, and they're probably just similarly on the cusp of moving from research to commercial. But I'm sure they'll get there, within the next few years.
So for anybody in the audience who's not familiar with the term, as I understand it, environmental DNA is a technique that makes it possible to detect which organisms are in a body of water without necessarily actually collecting the organisms, because the DNA is going to be present in the water, even if you haven't caught one of those particular organisms. Is that right?
Yeah, pretty much, Robert.
Yeah. I really wanted to go around everybody really to say which are the emerging technologies, perhaps moving on from eDNA. But generally speaking, what are the kind of emerging technologies that potentially look the most exciting? Kristian, any thoughts on that? What are you seeing that maybe you haven't got access to right now, but would be great to have in the future?
Yeah, that's a challenging question.
What's on your Christmas list?
I think like I hope that we will see a bigger utilization of all the data that we're collecting, and actually seeing some significant development from all the data. Like right now we're I think, like I said, the computer vision stuff that we're seeing now is super exciting. But I would like to see kind of the AI move from just computer vision to more into the deeper analytics on a more holistic view across all the data that we're collecting. So yeah, that's kind of where I hope to see big progress in the years to come.
Tim, what are you seeing on the horizon that looks of interest?
I think for us here, one of our key focuses has been gill health with salmon, and I understand it is an emerging focus in other parts of the world as well. So I think if we could utilise predictive modelling more on algal species and microjellies and things like that can have an adverse impact on gill health, I think that could be quite powerful in terms of planning operations and production planning to avoid algal blooms or microjelly occurrence. So that could be quite powerful. And just to resonate Kristian's comment around the utilisation of big data as well. Like I mentioned before, a lot of data is collected, but it's how you actually use that to make your decisions when it comes to achieving best farming practices.
Keith, how about yourself? What sort of technology, or what do you see kind of emerging that might change what we know about the marine
Yeah,
environment?
I was going to say very much that what Tim just said about modelling, really, that at the moment we're perhaps getting quite good at monitoring and seeing what's happening at a particular time and getting that data available in near real time. But if it's a gill health issue, certainly for the farm, it's possibly too late. So there are increasingly good advective models that might say, well, farm A's been hit, and we can say that the bloom is heading towards farm B, but not farm C. But I think that there's with the much more abundance of data and as well the environmental data that will understand what the drivers of some of these things are, putting them together so that we can have models that will really tell us when a harmful event's going to occur before it's occurred will be much more powerful. So that's one thing, and probably the other thing to mention is that maybe remote vehicles. There's a lot of development of remote technology. So it's not just occurring at the farm, but it can occur round about. At the moment, these are pretty costly, particularly. But the electric car manufacturing industry will probably drive down the cost of batteries, which is a major cost in that, and hopefully then reduce the payload weight that will allow you to put more sensors on. So it may be possible to do much better sort of spatial monitoring around about farms than we currently can do.
Great. And Kevin, what are you seeing that looks potentially exciting?
Yeah, we don't expect there to be a big, bold, disruptive tech that comes in and solves all the problems. As much as AI is pitched like that sometimes, but we offer solutions, digital solutions to the industry, and those have to solve problems. And there's loads of different pieces to that. And the first is, of course, the monitoring. And unfortunately, we're limited by the monitoring technologies, effectively the sensors out there. So, we've been able to monitor things like dissolved oxygen optically for a long time, and others, which is great. But then, things like sea lice were out of reach. But now with cameras and machine vision, effectively a camera and a machine vision model behind it as a sensor, that suddenly makes that parameter. And so, hopefully we're closing on a lot of the gaps in the monitoring piece. The next step is, of course, well, now we've got all this data coming off a site. How do we get all the insights and all the information from that? And I think one thing that's not been touched upon is monitoring and knowing problems is one thing, and it's important, but you need to be able to do things with it as well. And so what we are really interested in is closing that loop. So the monitoring and then the action. So remote autonomous monitoring and then remote and possibly autonomous actions and control to close that loop. Because knowing that something is happening is great, but if you can't do anything about it, it doesn't really change a lot. So new technologies and levers that operators can use in order to solve the problem. So, seeing the problem emerge or predicting it will come and then being able to do something about it is really key. And at the moment, there's not a huge amount of things that can be done. There's the sort of ultimate harvest now if things are really bad, but hopefully there are some new technologies out there that can help. We've seen bubble curtains, we've seen physical curtains, we've seen possibly moving farms, if that's possible, all sorts of things, submersible cages, the more tools I think are at the disposal for producers. And then, as an integrator, we want to be able to link all of these up to the monitoring, and that will hopefully give, the best chance at growing healthy and sustainable stock.
Great. Well, look, thank you all. It just remains for me to give a very brief summing up. I mean, clearly, fish farming takes place in a complex environment, but also a very challenging environment. Challenging both in terms of collecting that data and also challenging in terms of having the connectivity to transmit data and to enable remote monitoring. So the challenges are certainly there. We've certainly seen that the benefits are there. I think one of the insights we've had is that farms can, in various ways, spread the cost of technology if they are prepared to share data, although, of course, that has its own challenges as well. Artificial intelligence obviously cannot be ignored. As Kevin said, it's not a magic wand that will fix everything, but nonetheless, it looks like it is going to be part of the solution for many of the issues that we'll be facing going forward. And I guess the overall conclusion is that you can gather huge amounts of data, but what really matters is the insights that that data gives you, the ability to guide action, and that's really how it can be judged, not really how much are we collecting or how clever the technology is, but how that technology can be directed to improving productivity, improving fish welfare, and basically managing farms more effectively. So thanks to our panel, Kevin Quillien, Keith Davidson, Kristian Blom, and Tim Shepherd. And thanks to our audience for participating as well. And thanks for all the great questions we've had. If we didn't manage to get around to your question, apologies, but we hope that you found this an interesting discussion. And I'll see you next time.
Thank you, Robert. It was a pleasure. Thanks, everyone.